All right, guys, we are going to be doing a quick genetics review. Then we're going to practice completing a Punnett square just to make sure you have a basic understanding of how to actually use the Punnett square. All right, so let's review some of the vocab that you've been learning for this chapter so far. We have a gene, which a gene is a part of a chromosome that has the genetic information for one specific trait. If you don't have these notes or if you don't know where they are, you're going to want to write this down, okay? Let's keep moving. If at any point you need to write this down, you're going to hit pause. Then we have an allele. An allele are basically the different forms of a gene, okay? And something you need to know is that every single gene is made up of 2 alleles. I will ask you that. You need to make sure you know that for every trait, every gene, there are 2 alleles that make up that gene. Genotype. Genotype refers to the 2 alleles that control what a gene looks like or controls its phenotype. Phenotype is how a trait appears or how it is expressed, or in other words, it's basically the physical appearance of that gene, what we're going to physically see. So, for example, someone with brown eyes, when we look at them, we don't actually see their genotype because it's embedded in their DNA and we can't see that. But just looking at them, we see their phenotype, which is the color brown for brown eyes. Okay, let's keep it moving. Dominant is a genetic factor that blocks another genetic factor or the factor that takes over. And we use a capital letter to represent a dominant gene or dominant factor. So for example, here I put down a capital R. Recessive refers to the genetic factor that is blocked, and we use a lowercase letter to represent a recessive factor. All right. Homozygous. Also, I want to mention that you really need to know these vocabulary words. If you're not studying these vocab words, you're really not going to do well for this chapter. So you need to make sure that you are actually studying and learning what these words mean. Okay, so homozygous refers to 2 alleles that are identical or exactly the same. Now, for homozygous, there are 2 different possibilities. We have homozygous dominant. That means that we have 2 dominant alleles together, or in this case, we have 2 capital letters. Or homozygous recessive, which is when we have 2 recessive alleles together, or if I'm talking about letters, 2 lowercase letters. And then there's heterozygous. Heterozygous refers to when you have 2 different alleles, and there's only one possibility, a capital letter and a lowercase letter. Okay, I'm going to keep moving. If you need to write any of this down, hit pause. All right, so let's practice now, okay? When solving a Punnett square, there are 4 possible outcomes, 1 for each box. Now, each box is 25%. When you add it all together, the 4 boxes give you 100% of all the possible outcomes for that trait for the offspring. So let's just complete the bottom part of this. Okay, we're going to do it together. All right, so let me change the color here. Let's do blue. 0 out of 4. So let's say we were to fill in the Punnett square and none of the offspring had the trait we were looking for. So 0 out of 4 would give us 0%. Okay, so what do you think 1 out of 4 would be? It should be 25%. Okay, you should have the idea by now. So what would 2 out of 4 be? Got it, 50%. 3 out of 4 is, ding, 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 75%. And 4 out of 4 should be 100%. Okay? So again, each box is 25%. Let me write that down. Okay. All right, let's move on. Let's actually do some practice now. Okay, so in this case, a capital R, so we're talking about color here. Okay, the trait is the color. A capital R tells us that the phenotype would be red. Capital R is red. And I'm going to use black here. A recessive allele, a lowercase r, is white. Okay? All right. So now let's fill in the Punnett square. So basically, we have two parents here. One who is heterozygous and one who is homozygous, recessive. Okay? So this is how a Punnett square works. The one parent who is heterozygous, it doesn't really matter where you put the parent as long as the two alleles that represent the parent are on top together or on the side together. So for this one, let's put the first one. No, that's not what I wanted to do. Let's put the first one, this guy, over here. So a capital R and a lowercase r. And let's put the second one on the side here. So that means that this parent, the top parent, is what color? It's red. Even though he's carrying a recessive allele, he's red because he has that dominant capital R. And on the side here, that parent is white. We have two recessive alleles together. There is no dominant allele there to take over and make it red, so it's automatically white. So now let's fill in the Punnett square. Let's use blue for the Punnett square. Okay, this guy comes down, and this guy comes over to the side. So for this offspring, what color are they going to be? We have a dominant capital R that represents red and a lowercase recessive r that represents white. When they come together, we would only see red because that capital R, that dominant red allele, is going to take over the trait. So even though he's carrying the white trait, we won't see it. Okay? Let's move on to the next one. What do I want to do? This guy comes down, and this one comes over. So when you fill it in, you should get that. Two recessive alleles together. So what color would that be? Is there a capital R there to take over and make it red? No. We only have two white alleles. Okay? Remember, lowercase r represents a recessive white allele. So in this case, the offspring would be white. Okay? You're going to bring this one down and this one over. So you get a capital R and a lowercase r. Again, this is red. And then the last one, bring that down, bring this one over, and that should be white. So now let's fill in the Punnett square. Let me see if I can move this over. Here we go. All right, so let's answer the questions now. Okay, so what is the percent chance of getting two capital R's? So now look in the four Punnett squares. Okay, look in these four. Here's 1, 2, 3, 4. Do you see anything that looks like this? No, so the answer should be 0. Okay, what is the, so 0%. What is the percent chance of getting this? So again, look in the four Punnett squares and see how many boxes you have. So you have this one, 1, and this one is 2. 25 plus 25, that is 50%. Okay, what is the percent chance of getting homozygous recessive, which is 2 lowercase r's? Okay, so you're looking for this. How many boxes? You should see 2. 1 here, 1 here. So each box is worth 25%. You should get 50%. All right, the next one. What is the percent chance of getting red? Okay, now we wrote it out. Again, anytime you have that capital R present, it's automatically red. It takes over. So count how many boxes have a capital R and add them together. Remember, each box is 25%. You should have gotten 50%. Okay? And what is the percent chance of getting white? And you should, so you're looking for 2 lowercase r's for white, because you do not have a capital R there, so the red will not take over. And you should see 2 boxes, and again, that is 50%. All right, I want you to hit pause and try to complete number 2 at the bottom. Now, hit pause. Hit pause. Hit pause now. While I erase everything, you should be hitting pause. Hit pause. Okay, welcome back. All right, let's try to do the next one. So, you should be writing one parent on top, So I am taking this guy, I'm writing him on the side, and one on the, on the top, and I'm going to take this guy and write him on the side here. Okay, fill in the Punnett square. This guy comes down, and this one comes over. Okay, this one's going to come down, and this one's going to come over. This one comes down, this one comes over, and again. Okay, so now let's answer the questions. What is the percent chance of getting 2 capital R's? Do you see any of that in the Punnett square? So let's see, do we see any of this? Oh no. Okay, sorry about that. Let's keep going. So there is a 0% chance. What is the percent chance of getting heterozygous? We have 1 box, we have 2 boxes, we have 3 boxes, and 4 boxes. So altogether, that's 100%. Do you see any that look like this? No, so that's 0%. Now, what is the percent chance of getting red? Well, let's see. There's a capital R here, they're red. There's a capital R here, they're red. Anytime that capital R is there, it's going to take over. It doesn't matter if they're carrying a white one, a white recessive. They're red and they're red. So your answer should be 100%. And finally, what is the percent chance that the offspring will be white? 0. Okay, we will do more practice with this. I hope this helped a little bit. At this point, if you're still confused, that is normal. We just started this unit. Okay, guys. Bye.